Hello, I'm James Ingram for AutoControls.org. Welcome to video number 826. This is a continuation of the previous video, 825. We just added a second train on the same circle of track using the same Z-stuff detector as we had before. And just to review, we're using an NCE brand DCC system and an NCE Mini Panel to automatically operate two MTH O-gauge Proto 3 locomotives on the same loop of track. The NCE Mini Panel that we're using to control this operation is a $49 off-the-shelf simple programmable controller for DCC model trains. As for the locomotives, the yellow loco you see in the front parked there is a Premier locomotive, and the green loco parked in the rear is a Rail King loco that has had the DCC switch added to it, plus a rooftop light has been added. This was done courtesy of a very talented repair person in southeast Pennsylvania. And as you may already know, all the Proto Sound 3 Premier locomotives come with the DCC switch, but all the Proto Sound 3 Rail King engines don't have that switch. You have to add it yourself or have somebody do it for you, unless it's one that was built early from 2011 to 2014. Then they do have the switch on the Rail Kings. And finally, a warning about the power supply. I'm using what is called an NCE power cab for this system, and NCE says not to use the power cab for O-gauge trains because it's too low amperage and too low voltage. But don't let that confuse you, because all NCE DCC systems operate about the same other than their amperage capability. So everything you see in this video will work on any of the NCE DCC systems. I can make the power cab work here for this little layout I have because I'm running slow and I'm only pulling 2 cars each. In the previous videos I was using the old 1.3 amp power supply. For this video I upgraded my power supply to a new one which has 1.8 amps. In closing, I want to mention the simplicity of this layout. Basically, we're operating 2 trains in what I think is a fairly smooth, elegant fashion with a very simple hardware configuration. We've got no blocks in the track. The only 2 wires going to the track are the power wires, and we have one Z-stuff detector that sits next to the track. We don't even have to wire it into the track or cut any blocks to have it activated. I'm going to go back there and lift it away just to emphasize that point. Here's our, right here is our track connection. This is the only 2 wires going to the track, 2 power wires. And then back here is the Z-stuff detector. I don't know if it shows, but when I interrupt it with my hand, it goes from green to red. But this is just sitting next to the track, so it's easy to remove it or move it to a different location if you want. Very convenient. And thanks for watching. Here's the same setup we had in the previous video, 825. And we've still got our push button here we can offer to the public that they can push, which I'm going to do now. And that will start the front train up. This is the same hardware as the previous video, it's just we've added a second train and we've added a little routine to our controller to operate 2 trains on the same loop of track. Running both these engines at speed step 4, fairly slow, but just fast enough that it looks like they're moving and going someplace. And you can see what happened as before with the push button. It just makes a single sequence around. You notice it parks the yellow engine up front, and it parks the green engine back by the station. So if we push that button again, we'll get another cycle. So again, this is something that could be set up for a public display, and the trains would wait until somebody came along and pushed a button. Now when that green train gets over to the station, it'll check input 1 like it did before, and since nobody's pushing on the push button, it'll park the train. So that can be operated as kind of a public thing. And we got the same option as before. We can push the close a switch on the operator's control panel, which will hold input 1 grounded continuously, and the trains will run in a continuous mode. Let's do that now. I just closed that switch, which grounded input 1, which has the same effect as somebody standing there holding the push button continuously. So these trains will do that operation in a continuous mode. And note the logic of how this works. When that green engine goes past the detector, it honks a horn, and then the controller executes a delay statement which pulls the green train forward to the station, and it'll sit and wait until the yellow train crosses the detector. Note this is our minimum distance past the detector. We have to pull those trains forward of the detector far enough that when the next train comes in, it won't run into the rear of the stop train. And again, that's done by a delay statement. And these will run, continuously like this, assuming no derailments or stalls or glitches. This will run continuously like that until that switch is opened over there. And we were able to put in a routine to honk the horn when the engine goes past the detector, and that's optional. It doesn't have to honk the horn. Now I just stepped over there and opened that knife switch, so the next time that green engine parks back at the station, the routine will check if input 1, which is the switch, is closed. Since it's no longer closed, it'll park the trains in the original starting position. Notice now both trains are parked, and they'll sit there and wait until somebody either pushes the button again or closes the switch to start them up. If I push the button, you can see they go back up into startup mode, and the sequence will keep repeating. Now we can do one other variation. Notice I mentioned the delay caused those trains to pull in by the station. We can add some additional delay from when they go past the detector to cause them to pull up further about to where that green board is by closing a switch I added on input 9 just as a test. And let's take a look at that now. I'll start the trains up. Now they're running in their normal sequence. Stopping over by the station. And incidentally, I've upgraded my power cab supply, which is over here. I've upgraded that to a 1.8 amp, so we now have a massive whopping 1.8 amps to operate this system. With the previous 1.3 amp system we were using in the previous video, it did cut out occasionally with 2 trains. Now I'm going to go over there and close that switch right now. This switch here. That little switch sticking up in the air. Watch what happens. You see the yellow train's not stopping at the station anymore. It's going to come up and stop about where that green board is. That basically adds some additional delay to the time when the train crosses in front of the detector till when the controller tells it to stop. The effect this has, besides stopping them further down the main line, it keeps them running longer. You can see if you watch the yellow one, it'll just stop, and it just gets stopped before the green one goes in front of the detector, and then it starts up again. So this keeps them running almost continuously. And this is the maximum delay we can have for this little layout, because the key thing to notice is as that yellow engine's pulling up there, it's executing a delay statement to get it up to this board, and that delay statement has to be done before the green engine crosses in front of the detector. If it's not, the controller will miss the fact that the engine crossed in front of the detector, because it'll be busy doing the delay statement. On a larger loop, you could cause more variation of where it's stopped, but on a small loop like this is kind of our limits. Now I'm going to go over and open the original switch number 1. I just opened our switch that causes continuous running, so next time those trains, okay, there they are, they stopped. Now if we push the push button again, it'll make another cycle from the new starting position. Now since the input number 1 for continuous running is not closed, they'll come up and park themselves here again. Let's start them up in continuous mode. Now we're back to running continuous mode. If I go up and switch that little switch sticking up in the air that's hooked to input 9, if I open that switch, it'll cause it to go back to the shorter delay. I just opened that added little switch, which will cause it to do a shorter delay. You can see now they're parking back at the station, back in the rear, the original parking position. This is obviously optional, but you can add that switch to include or not include the additional delay, which will change the stopping point of the trains. And that'll just keep operating continuously until we open the switch to stop it again. I put the power cab up close so you maybe can see the amperage as it's running. And again, I got to repeat, NCE says we shouldn't be using the power cab for O gauge, but I'm doing it because I can stay within the amperage provided by the unit. I'm not overloading it or anything, especially with the new 1.8 amp power supply. What I really wanted to show over here on the control board, and again, this is our NCE Mini Panel that's doing the controlling, but this is that switch I just kind of added in here, and it goes down to input 9. It could have been any unused input from 5 to 30 essentially, as long as it's not an input we're already using. Input 9 was just convenient to wire it in, and the other end goes to ground. So when we close this switch, it grounds input 9, and I added a check in the routine. If input 9 is closed, do this additional delay, and that's what causes the trains, instead of stopping back there, to stop up where that green board was, as you saw in the last demo. Here's video 815, which shows the same kind of a system operating on an HO gauge track. What we call the long delay is in effect here. Trains are stopping at what we call the upper station because of a longer delay. The sensor is over here. It's a reed switch in the track by this building. The controller is on this brown board over here out of the picture, but you can see the corner of it. Now in a minute you'll see the person in the film, that's me, reach over and open that switch to create the shorter delay. Now the trains will stop at what we call the lower station because they're going a lesser distance past the detector. Now there's the shorter delay. Now I've just reached over in the video and increased the delay again, so next time this train will stop at the upper station up here because we have a longer delay. So this shows on a longer loop of track how we can change a delay to get different places a train will stop. Here's video 819, that same HO layout we were looking at a minute ago, except now we've got 3 trains running on it. You see the same brown control board here, and here's our controller, what we call the mini panel. Over here is our Z-Stuff detector. The general scheme of things is we have 2 trains creeping in the yard, 1 train running on the main line, and when a train comes in off the main line and passes this detector, it'll slow down to what we call slow creep speed. There, that one's at slow creep speed. The one that was in the front in the yard will be put out on the main line at cruising speed. So at any given time we've got 2 trains in the yard and 1 train out on the main line. Or said another way, each of the 3 trains takes its turn running around the main line loop while the other 2 are creeping in the yard. And now we're looking at the AutoControls.org video page. Here's the listing on that page for video 815. That's the one we were just watching with the 2 HO trains running. And let's scroll down here a bit. Here's video 817, which uses the same basic scheme of operation, except we were operating on an outdoor large-scale layout to control 2 trains. And then scrolling down some more, we have video 818, and this showed 2 S-gauge trains, the rear one here and the front one here, that were operated using this 2-train system. This one actually ran at the 2017 National Association of S-Gaugers convention. And then finally, we have video 819, which is kind of interesting. This is that same HO layout we saw a minute earlier. When I'm writing the commands for these multi-train operations, I found it's helpful to create what I call a logic diagram, and here's the one for the operation in this video. We've got 4 parts to it, as numbered on the left, 1, 2, 3, and 4. And what that breaks down to over here, we've got a starting sequence, a part 1 operating sequence, a part 2 operating sequence and then the ending sequence. And these show the positions of the locos in each of those 4 parts of time. Now when we begin starting, both engines are sitting here. The green one's sitting back in the rear by the station, and the yellow one's sitting in front of it. So the first thing we do is we select that loco 101, give it a speed forward 4 command, which starts it moving. So that after we do that, that loco will start moving around the circle, and it'll be coming down this side of the layout, approaching the detector. At that point, we move down to this second diagram, which says operate part 1. And here's our loco, yellow loco, approaching the detector. And these lines behind the loco is my attempt to make it look like the loco's moving. So in that detector, the command we've got in effect now is wait until input 14 is ground. So when that loco goes past that detector and blocks it, the Z stuff relay closes, which grounds input 14 on the mini panel, and then it'll start executing the next commands. And what it does at that point, it selects loco 779. That's the green one that's sitting here, gives it a speed forward 4 command to get it moving. So that gets 779 moving and starting down the main line. And then meanwhile, when the yellow one comes around the corner, that's being controlled by a delay statement. When the delay statement ends, which gets it up by the station, we select loco 101, that's the yellow one, and give it a speed forward 0 command. So after we've done that, things look essentially like shown in part 3 here, or part 2 of the operating sequence. We've got the yellow one parked at the station and the green one moving on the main line. So that's the same thing as above, except everything's reversed. We got this wait until input 14 is ground statement going, and that means nothing happens till this loco reaches a detector. When it gets there, it proceeds to the next command, which is select loco 101, give it a speed forward 4 command, and that starts the yellow and 101 moving on the main line again. And meanwhile, the delay statement that's executed next will bring the green one around to the station, and when that delay statement expires, we'll send the command select loco 779, the green one, and speed forward 0, which will stop it. So what's shown in the yellow box here is what will happen as long as this is operating. It'll keep switching between these two states while things are operating, and that's when the switch number 1 on the operator's panel is closed to keep it operating. Now, if someone opens that switch, which means the operator wants to stop the trains and park them, what will happen when the green one comes around again? What will happen? We'll select loco 779, but we'll give it a speed forward 0 command, which will stop it. And then this one we'll select that loco and give it a speed forward 0 command, which will stop it. So at that point, both locos will be stopped and they'll sit there. And then when someone closes switch number 1 again or pushes the push button connected to input 1, we'll be back up here at the top, executing the starting sequence. Here's the commands that correspond to that logic diagram we were just looking at. And this is the simple version. It doesn't include the horn blowing, and it doesn't include the extra optional delay statement we saw in the video. This is just a simple version, but corresponding to the logic diagram, we start here selecting loco 101. That's a yellow one, and we start it up speed 4, which gets it moving, and then we're waiting for input 14 to go to ground. Then we select loco 779, that's a green one, and start it up. That's what happened when the yellow one passes the detector. The green one sitting in the station, we want to get it moving. So we select local 101 again, and we delay 20 seconds, and that, a quarter second times 20, that's 5 seconds. That brings the yellow one around to the station. We send it a speed forward 0 command, which parks it. Now we're halfway through the sequence, and the same thing's going to happen all over again, just reversed. 779 is out moving on the main line at this point. So again, we're waiting till input 14 is ground. That means the green one has crossed in front of the detector. At this point, we'll give 101, the yellow local, a speed forward 4 command to get it moving from out of the station. Then we'll select 779 again. We'll delay for 5 seconds, which will bring the green one, 779, into the station. Give it a speed forward 0 command, which will stop it at the station. So at this point, we've completed one complete cycle, and we'll do our test as to whether we want to repeat this sequence or stop, depending on if the switch is open. If the switch is closed on the operator's panel, which means we want to repeat the sequence and keep running, this test will be false, so it won't skip the next line. It'll hit here, which is linked to input 19, which means we go up to the top of this thing and start it all over. Now, if however the switch is open, which means the operator wants to stop, then we skip over this next statement and we go down here. And 779 is already stopped at the station. We select 101, give it a speed forward 0 command, and that'll stop it. So at that point, both locations will be stopped. Both locomotives will be stopped, sitting there idling, and they'll wait until somebody pushes the button or closes a switch again. Here's the commands for how we ran those locos as seen in the video. It's the same commands we looked at a minute ago, except these 4 blue rectangles you may see here show the additional commands we put in to blow the horn and add the extra time delay. Up here, we've got loco 101 selected, so you can see now we're turning the horn on. We're delaying a second and turning the horn off. That makes loco 101 blow the horn when it goes past the detector. And then this pair of commands pertains to input 9, which is that little blue switch that kind of stuck up in the air. If we close that switch, that adds an additional 5 seconds delay, which means that the engine 101 will go past the station and park a little bit further downstream, as you saw in the video. And then because it's a skip if the input is open, so if the switch is closed, it'll add the extra delay. If the switch is open or the switch is not even connected, then it'll skip this extra delay statement and not do the extra delay. And then the same thing is down here, and this is pertaining to loco 779. That's the one that's selected. We have turned the horn on, blow it for 1 second, and turn the horn off with these statements. And then down here, the same thing to add the additional delay. Skip if input 9 is open. That means if it's closed, it'll execute this statement and add an additional 5 seconds delay, which will cause the train to travel 5 seconds further before it stops. And then everything else is pretty much the same. If you actually use this file, and I'll try to get a copy of this at AutoControls.wordpress.com, where I've been trying to keep the latest files. If you use this file, you would just have to change your engine numbers to match your locos and experiment with the delay times to match your layout. And remember, this is what you're seeing here this is just a word processing file that I use to document all this stuff. You actually have to enter this into the mini panel, and that's what this column is for. I enter these numbers, which puts the commands in the mini panel. And if you were doing it, you would just probably the easiest way is to use what they call a no-op statement. Let's look down here at the bottom. You see the last line says no-op. That's a do-nothing statement. It just passes through to the next statement. Everything in blue which I think is 10 lines total. You could put no-op statements to initially get this working. Then when you got it working, you could go back and replace the no-op statements with the actual statements like what are shown here. Because remember, the mini panel, you can't slide commands around like you can in a normal computer program. Wherever you type them, that's where they are. And if you want to change them, you have to type them over and re-enter them in a new location. So it's good to try to plan ahead as much as we can. So that's why I say put no-op statements to reserve the space for like these commands, 3 commands here, and these, these 3 commands here, and these 2 commands here.